This question is from Gate 2021 Mechanical Engineering paper set 2, question number 37. A cast product of a particular material has dimensions 75 mm by 125 mm by 20 mm. The total solidification time for the cast product is found to be 2 minutes as calculated using Korinov's rule having the index n equal to 2. If under the identical casting conditions, the cast product shape is changed to a cylinder having diameter 50 mm and height 50 mm, the total solidification time will be dash minutes. Let's find out. So we'll start by writing the given things. The dimensions for cube are given to be 75 by 125 by 20 mm. Solidification time for the cube is given as 2 minutes. Korinov's index is given as 2. For cylinder we have diameter of the cylinder is 50 mm and height is 50 mm. So we can see that D is equal to H, and we need to find out the solidification time if the casting is cylindrical. Now we know that by Korinov's rule we have solidification time is equal to a constant K into volume of the casting upon surface area of the casting A raised to n, which is this index that is given here 2. So we can see that the volume and surface area are going to be different for the cubical and cylindrical casting, and depending upon these two values, the solidification time will change for the two. So we need to find out the solidification time for cylinder knowing its volume, because D and H are given, we know the volume, also we know the surface area. For cubical, time is already given. Using the information given for the cubical casting, we can find out K first, and then using this K, we can find the solidification time for cylindrical casting. So let's do it. For the cube, we have solidification time of 2 minutes. So we have 2 is equal to K into volume for cubical casting will be 75 by 125 by 20, while the surface area will be 2 times 75 by 125 plus 2 times 125 by 20 plus 2 times 75 by 20 raised to 2. This turns out to be K into numerator is 187,500 millimeter cube divided by the surface area turns out to be 26,750 millimeter square to the power 2. From here we get the value of K. So K will be equal to, this value is 7 and 7 square is 49. So K will be equal to 2 upon 49. Now that we have K, we can find the volume for cylindrical casting and the surface area for it, and then find out solidification time for cylindrical casting. So let's do it. Second part for cylinder. Volume is equal to pi by 4 D square into H. D is equal to H, so we have this value as pi by 4 into D cube. Surface area will be equal to 2 times the area of top and bottom circle, which is pi by 4 D square, plus the curved surface area, which is pi into D, the perimeter, into the height, pi D H. So this area turns out to be 3 by 2 pi D square. This ratio V by A for cylinder will be pi D cube by 4 upon 3 by 2 pi D square, which is equal to, this gives us D by 6. So substituting it for cylinder, we have solidification time for cylinder is equal to K is 2 by 49 into V by A is D by 6 square of it, which is equal to D is 50 millimeter. Substituting that, we have for cylinder the solidification time will be 2.83 minutes. Let's go back and fill in this answer. Rounded off to 2 decimal places, we have the solidification time will be 2.83 minutes for the cylindrical casting. To learn more about riser systems, you can refer to the NPTEL video Design of Riser System 1. It's from the course Metal Casting. The course is taught by Dr. D. Benny Karunakar. He is from Department of Mechanical and Industrial Engineering of IIT Roorkee. I hope this solution helps you clear your doubt. Thank you.